This is a picture of my wife's Toyota Tacoma front end, and what I'm trying to show you here in this video is what I believe is a design flaw for the lower ball joint. What I mean to show you here is the spring you can see up in front pushing down on the lower control arm. Alright. Now, when you look here, this is the lower control arm. This part right here is attached to the ball stud of your ball joint. And this is the ball joint. It's connected to the spindle assembly here that rotates when you turn your steering wheel. And the spring pressure that's pressing down on the lower control arm is trying to pull the ball stud out of the ball joint housing rather than to press it in under normal use. Now, most vehicles for their lower ball joint are oriented just the opposite of this. Now, what you would normally see is that the ball stud housing would be pressed into the lower control arm, and then the stud would, instead of pointing down, would be coming up and come up through a socket in the spindle, and then the nut go on. So it would look similar to that, but it would be attached to the spindle. And when the spring pressure was pushing down on the lower control arm, it would then be pressing the ball stud into the socket. And when you do that, the ball has a whole lot more surface area that it's in contact with when it's in operation. Plus, in its failure mode, as the ball socket wears, it doesn't tend to try to pull out of the ball, the ball stud housing. It tends to keep pushing it into the housing, and then typically you would start to see tire wear, and somebody would find that it was loose, and it wouldn't fail in a catastrophic way where the ball would come out of the ball housing like what happened on this truck on the other side. When that happens, it drops the wheel out from under the truck. At any rate, I'm gonna go show you some ball joints at my shop that I have disassembled to inspect the quality of, and meet you back there in a second. Okay, I'm back here at my shop, and this is the ball joint that failed in the truck. And when you look down in the inside the joint, you can see that there's some kind of a plastic, nylon or acetal or some plastic material that makes the socket, but it's a one-piece thing, and you can see the parting line on it. It's pretty defined. It's like you're not seeing a worn to the metal issue here. It's machined, and where you see the plastic is all that was ever put in there, from best I can tell. And the way that this joint failed is it pulled apart. You can look at the ball here, and you can see that the side, if you look at the part of the ball that would have been down in the socket, it's rusty and black. It looks like it's never been rubbing anything. And you look at the side of it that would have been pulling up out of the hole, that's the side with all the wear. It's like the bushing is in the wrong place, or the bearing surface is in the wrong place. The only thing that I can think was there to hold the ball in to begin with is this little bit of metal right here. Came on in a little further and probably had a radius machined on it, and when the thing was in normal operation, all the pressure was pulling the ball out towards this metal part, and it just kept wearing until it pulled through. And in its failure stage, the ball actually froze as it was coming out of the hole. It froze, and when you turned the steering, the whole ball stud rotated, and it caused it to shear the cotter pin and make the nut come loose that held the ball stud into the lower control arm. So not only did it eventually pull out, but it was going to come unthreaded and fail that way as well. Anyway, this isn't the first time that's happened to this vehicle. When we bought it, the ball joints had been replaced, and the guy we bought it from was a friend, and he told us he had just had them replaced and it needed to go to the alignment shop first thing before we did any more driving, and we did immediately. It went to a alignment shop in our local town of Lexington, and it was done. And of course, you notice this joint doesn't have a grease fitting in it. You know, they put the grease fitting on these joints either here or here. I think it's in this side right here. If you look at some of the other joints, the grease fitting would have been here if it had a grease fitting. So there was never a way to grease the joint as well. And it appears to me that the person who built this joint assumed that it was going to be used in a mode that would have been pushing the ball into the socket, and that the nylon bushing down in the bottom was there to support the load. But obviously they had it all wrong. I mean, this joint is being pulled, so all the load bearing surfaces are on the top from the middle of the ball to the top edge. Those are the load bearing surfaces, and they're riding in this case against the metal, because this part of the plastic bushing, it's essentially straight down for a short ways and then has the radius of the ball. So this little short area of metal right here had a little bit of a radius on it that was holding the ball in, and that's all it was ever, looks to me like all it was ever designed to do. Well, I bought several other replacement joints this time, because 2 failures like this is something I don't want to see again, and I don't want anybody else to potentially lose their life with a wheel coming off their car, potentially going down the road at a high rate of speed. And what I do know about it is that the original Toyota joints seem to hold up very well, even though this particular design doesn't make a whole lot of sense. The best load carrying capability for this type of joint would be to be pushing the ball into the socket, but Toyota has been able to have manufactured for them a ball joint that works pretty good whether you're pushing it or pulling it into the socket. And this one right here is the one I purchased from my Toyota dealer, McDonough Toyota, out in Stanton, Virginia. And it doesn't have a grease fitting either. But what it does have is a plastic bushing that covers the whole ball. It's probably impossible to see with the quality of the video from this little camera, but you can, with a flashlight and a good and a high resolution camera, you can easily see the plastic bushing comes all the way up to the top of the metal, right under the bevel, right under that inner bevel. And this joint works really nice. It's smooth. You can, with one hand, move the joint around. When it sits, it gets a little stiff, but as soon as you get it to pop loose and start moving, it's very easy to maneuver around, and it takes equal pressure to move it. Now, this is the joint I think I'm going to put into the truck, because I know that they have a reputation for holding up at least a couple 100,000 miles, and this joint didn't last but 8,000 miles. Now, that being said, I've heard rumor all over the internet on Toyota forums and so forth that this company called 35 Sankei Industry Company Limited in Japan was the company who made the original equipment ball joint for Toyota. But I also heard from a guy who seemed to know what he was talking about that Toyota contracts with several different companies, and maybe they would use this company 555 sometimes and some other company another time. Well, nowhere on this joint that I got from the Toyota dealer does it show the 555 emblem, and I'll show you what I mean about that on some of these other aftermarket joints that I do have. But I do like the way this one feels, and I do believe it'll hold up because the ball is highly polished. It's a large ball, and that should give it a little bit more load-bearing surface, and the bushing comes all the way up to the underside of the bevel right here on the joint. And so I believe that if I use this joint, it'll hang in there for a couple 100,000. But anyway, prior to buying the one from Toyota, I was online with a company who claimed that they sold the original Sankei joint that came with the truck, and this was their OE joint. And I'll show you what I mean about identifying it. If you look on the bottom of it here, and I don't know if that's legible in the picture or not, but it says 35, and it's got the little 555 oval and then made in Japan. And down here on the casting, there's a 555 as well inside that oval right beside the L for left. This particular joint has a grease fitting in it. Now, what I don't think it has is a plastic bushing in it, because it's nowhere detectable. I look back under the edge of the lip here, and I can't see any of the white plastic. It looks like it's metal to metal. So here in a little while, I'm going to cut this thing apart with my lathe back here on the back of it and totally disassemble it, and we'll look at it again in the video to see what it is. Now, this particular joint, it says 555 on it, but it's not the one that came in the 555 box. The one that came in the 555 box is right here. And it's got a bag, it came in a bag with the 555 emblem on it, and the made in Japan, da-da-da. And when you look at it, I've looked it over through the bag. I don't want to open the bag because then I can't take it back. It looks in every way identical to this ball joint that I bought with the Raybestos name on it. And I don't know if you can read it or not here on this back cover, but it's got the 35 emblem on it, and also right into the casting here you can see the 555 emblem right there at the tip of my thumb. And when I move the joint manually by getting a hold of it with two hands, it feels just like this one. And this one is rough. I mean, it'll move a little ways, and then all of a sudden it'll move a long ways, and with a jerking motion. And when you're moving it, you can also hear and feel sort of a grip and release motion to it, whereas the one from Toyota is very smooth. Now, like I said, this one was from Raybestos. Has the 555 on the back. This one was in the box 555. Looks identical, feels identical. And I bought a Moog one just to see what it was. And it also has the emblem with the 555 on it. Same markings on the casting, grease fitting, identical in every way. The Moog, the 3.5, and the Raybestos, at least this particular Raybestos, all appear to be and feel like, quality-wise, the same joint. Now, with that said, I bought another joint at the same time from Amazon as I bought this one Raybestos one. I bought two when I ordered them, and one has the 3.5s on it, and this other one just has a number on the back here. It's a 73015-062 is one of the numbers, and then the other number is a 1520. Now, I think that 1520 number is like the last part of the number of Napa's part number for the Raybestos joint, and so I'm thinking that this is either an older version of the Raybestos joint that may have been made in the USA, or maybe not, but certainly made differently than the other one. It's painted, and it has this blue, it came with this blue boot that goes over it. And what I like about it is it's built very much like the one from the Toyota dealership. It has a nylon or plastic bushing in it that you can see right under the beveled edge of the joint here. And I would guess that it goes all the way around the joint. And this joint, when you move it, it's stiffer than the one from the Toyota dealer, but it's smooth. It's equal amount of pressure in any direction that you move it, back or forth, up and down, whereas these ones with the 3.5s on them are jerky. And this one from Raybestos has a grease fitting hole in the side, but when you look down in the hole and you get it in the right light, you can see straight into the plastic bushing that the ball, which would be this ball socket, that's in there. So I'm not sure whether the joint will get any grease in it, even if you put a grease fitting in it and pump it. But I'll test that and update the video after I do it. There's another thing that I want to do too, and I'll do it and then add it as an update, is to cut this one apart, this 555 joint, and see how it's constructed exactly. But one point is, it looks like if you go online to buy these joints, that this one that's got the 555 on it is sold under many names. AC Delco sells it, Raybestos sells it, Moog sells it, Sankey Industry 555 sells it, and there could be others. Those I know of. I've seen the pictures of them online, and they show the 555s, and every visual indication would lead me to believe that they're all the same joint, sold under different names. At any rate, I'm going to proceed on with cutting this Raybestos 555 joint apart, and we'll do another clip. I've taken the joint apart, the one that's the 3.5s, 555, and the ball is not a complete sphere. But what I will say about it is, it was obvious in this design that they designed it to be pulled on, the stud to be pulled on rather than pushed in. At least the people that made this joint knew how it was being used and made it appropriately. Now, what I don't particularly care for is it's just steel against steel. Inside this joint, and I don't know how much you can tell about it with this video. But it's just the top half, essentially, of the sphere has a radius inside the joint. And the kind of blue tint to the metal you see down there is actually bluing from the hardening process that is still on the metal. And it's kind of the same with the ball. I mean, it's still got bluing on it and sort of black, and has marks through the, look like the machine marks from machining it are still on the ball. It's not a highly polished thing, but probably, since it's a joint that can be greased, if it were to be greased regularly, it probably would hold up a good while. Like I say, it was definitely designed to be pulled on rather than pushed in, because there is no bearing surface in the bottom of the joint like the one that came apart. What it has in the bottom against this side of the ball is a cupped washer that sits over the ball to press on it, and then on top of that, or in between it, is a rubber, I don't know what you want to call it, a washer or what you want to call it, but it's used as a spring to keep tension on the ball. And then here's the 555 plate that you could see when the joint was fully assembled. And this stuff just drops down in the hole on top of the ball when it's assembled into the joint. That's what you would see right there. That's the ball inside the joint. At any rate, this joint is probably usable. It's going to wear out quicker than the factory original, but I suspect it'll last considerably longer than a year. And so I'll give it a decent grade. Now, this other joint that I think is probably also built, well, I say also built, I think this joint is actually built by Raybestos, or whoever builds them for Raybestos, and not the 555 joint, which is made in Japan. Now, this joint may be made in Japan as well, but it's designed very much like the factory original. It has the plastic bushing around the ball. The ball seems to be a nice large ball, and to boot, it has a grease fitting so that you can grease it if you like. Now, I assume that after you've greased it a few times, you're going to swell up the boot, the rubber boot, and I don't see any grease vent built into the rubber boot on this one like on the 555 joint. So what you would have to do, if you notice that somebody had greased it too much, is take out the grease fitting and sort of squeeze on the boot and press some of the grease back out. And then if you wanted to put in fresh grease, I guess you could do that. But that would be the limit. I think the idea here is with this type is to grease it when you install it good, and then, maybe a squirt each time one pump of the grease gun each time you change the oil or something on that nature, and it would probably last quite a few miles. So I think what I'm going to do is I'm going to install this joint on the left side and the factory replacement one on the right side, and I'm going to mark them, and so I remember if and when they ever fail during the balance of the life of this vehicle. And assuming I get a quick failure like this one, or even 2 years or something like that, I'll get back on YouTube and let you know. But I believe both of these joints are going to be good ones. And really, for the dollar difference, when you go to buy these things at the store, the one from the dealer is approximately $100, and the Raybestos one, unless you get an extra good bargain on it, is going to be around $75. And so really, for the $25 extra, you're probably smarter to stay with the factory ball joint. That would be my opinion, and I would not mind hearing feedback from others who have had similar problems, and hear what they think about what I had to say here. At any rate, signing off.